From the moment peat formed by accumulated plant material is buried underground and gradually transforms into various coal ranks such as gas coal, fat coal, primary coking coal, and lean coal, we refer to this transformation as the coal forming process. It is also known as the metamorphic process. The driving forces of this process mainly come from three aspects: temperature, time, and pressure. Different sources and combinations of these three forces give rise to three distinct metamorphic models, which in turn cause coking coals formed under the same coal-forming environment and from the same coal-forming materials to exhibit significant differences in their technological property. These three different metamorphic models are protonic metamorphism, contact metamorphism, and dynamic metamorphism. Protonic metamorphism is the most ideal metamorphic process. However, the conditions required are quite strict. It requires a continuous and stable subsidence process to generate sufficient pressure and relies on the stable geothermal gradient underground, where the temperature increases by about 3 degrees for every 100 meters of depth, providing the energy required for coal to evolve over a long period of time. A typical example of plutonic metamorphism is the coking coal mined in Sxcoal. Its characteristics include a relatively dense coal structure and a well-developed but compact pore structure. Its carbon chain structure tends to form optically anisotropic components. At the same time, the coal formed under this environment has glutinous matter with greater stability and a favorable softening and melting temperature range. The second type is contact metamorphism. It usually occurs in coal seams that formed relatively late and were not buried to sufficient depths. Due to the intrusion of underground magma or the effects of magma produced by volcanic eruptions, local temperatures can become extremely high. This promotes the transformation of coal resources that would not normally become coking coal with different degrees of metamorphism. Typical examples of this type of coking coal are found in regions such as Xinjiang and Qinghai. The coal seams were formed during the Jurassic period. They were also not buried as deeply as those in Shaanxi or in North China, yet they can still transform into anthracite, primary coking coal, or fat coal. However, the primary coking or fat coal formed under these conditions has structural characteristics and properties such as melting behavior, caking ability, and coke strength that differ significantly from other coking coal. The third type is dynamic metamorphism. Dynamic metamorphism refers to metamorphic changes caused by major fractures within tectonic systems. For example, the edges of many coal fields are usually associated with large fractures. This includes major faults, such as those in the Fanway Graben of Shaanxi. These faults can reach depths of over 1,000 meters. On both sides of the fault, localized high temperatures or high pressures may occur. Under such conditions, the metamorphic degree of coal can increase locally. This is what we refer to as dynamic metamorphism. Coking coal produced by dynamic metamorphism is usually extremely unstable during utilization, and its reserves are also very limited. It can only be found in limited areas, such as around Jiaocheng County or in Xishan Mountains in Taiwan City, near the edges of major faults, where shallow coal seam may even have slightly higher metamorphic degrees than deeper ones. This is typically the result of dynamic metamorphism, but the amount of coal formed and used under such conditions remains quite limited.